Hello. These notes are starting off our unit on trigonometry, and they're about angles in standard position. Why is it important to talk about angles in standard position? Well, let's say I asked you to draw a 90-degree angle. Some of you might draw this. Some of you might draw this. Some of you might draw this. I'm putting that corner in every time to show that it's 90 degrees. But how can we develop a way so that no matter what angle you draw, everyone's picture looks the same? We have a position known as standard position. The way that we would sketch angles in standard position is by first drawing an initial ray of an angle. So we know that an angle is formed by two rays. I then measure my angle counterclockwise. So I'm measuring it this way, and I draw my terminal ray. So here is my initial ray. It was the first ray that I drew. And we can see that an angle in standard position will always have an initial ray that lies on the positive x-axis. Notice I started with an xy plane. The terminal ray is drawn after you sweep out whatever angle measure you want. So what angle did I draw, roughly? Well, my initial ray is, of course, on the positive x-axis. I know that I went more than 90 degrees, because that would mean my terminal ray was vertical. And I didn't quite go 180, so I don't know, maybe it's about 135 degrees? I don't know, that looks like I sketched about 135-degree angle. Notice that positive angles are measured counterclockwise. So with these rules for sketching an angle in standard position, if I said sketch a 90-degree angle, everyone would have the same picture on their paper. Initial ray on the positive x-axis, if it's a positive angle, measuring it counterclockwise, and then we can see wherever our terminal ray would fall. Let's practice this. Let's sketch 210 degrees in standard position. I know our initial ray, or the first part of our angle, always has to be on the positive x-axis. And if I think about going 210 degrees, I know that, let's see, I'm going to go counterclockwise. So here's 90, 180, 210 maybe right about there. If I went all the way down to the negative y-axis, that would be 270 degrees. Too much. So I have to be somewhat accurate. I want to make sure that I'm landing in the correct quadrant. What about a negative angle, negative 80 degrees? I don't know if many of you have dealt with negative angles before, but we can sketch them in standard position. Note that we're just measuring our angle clockwise instead of counterclockwise. But our initial ray is still on the positive x-axis, and I'm going to go 80 degrees clockwise. So that's this way. And notice because I measured it clockwise, it was a negative angle. So negative 90 would have been kind of all the way with that terminal ray facing vertically down. What are coterminal angles? Well, it's kind of right there in the word. Coterminal angles share a terminal ray. So let's investigate this angle 90 degrees. Let me sketch it in standard position. Can you think of an angle that is coterminal with 90 degrees? Well, what if I measured negative 270 degrees? If you imagine 90 degrees, we know that that's measuring counterclockwise for a positive angle. Negative 270 degrees is a different angle, but if you measure by starting on the positive x-axis with your initial ray, and then you would measure clockwise, because it's a negative angle, 270 degrees, your terminal ray would end up in the same spot as it did for 90 degrees. So we would say 90 degrees and negative 270 degrees are coterminal. If you sketched them without indicating which was which, they might look like the same angle, but they're not. What about this one? What if I took 10 degrees? Can you find an angle that's coterminal with 10 degrees? Well, let me think about sketching it. Here's my xy plane. 10 degrees, positive 10, so it's just up a little bit like this. You could imagine, what if I went the other way? And if I go all the way around, that would be like negative 360, but what if I did like negative 350 and I measured it this way? Here's negative 350 degrees. Are those the only two angles where the terminal ray will land in this spot? Well, no. What if I did 370 degrees? Are we allowed to measure angles that are greater than 360? Absolutely. What that would look like is I went around 360 degrees and then another 10 degrees. So it looks kind of funny. We went around one whole time plus a little bit. But these three angles, 10, negative 350, and 370, are all coterminal. If I didn't indicate the direction of the degree measure, they might all look like the same angle. They all share the same terminal ray, so we call them coterminal. Note that the angle measure is actually different, though. The way that we sketched it was different. We just always landed in the same spot. One more vocab word, and that is known as a reference angle. So because we can have multiple angles that look the same, that are coterminal, it's important to talk about the reference angle, and that's defined to be the angle between 0 and 90 degrees that's formed by the terminal ray and the x-axis. So let's start off with an example. How about 210 degrees? We sketched that earlier. I know that in standard position, our initial ray is always on the positive x-axis. Our terminal ray lands in quadrant 3. So here's 210 degrees. Our reference angle is between the terminal ray and the x-axis. So our reference angle is actually this smaller angle right here. And notice our reference angle is not drawn in standard position. It almost never will be unless we have just a first quadrant angle. So this is our reference angle, and sometimes I abbreviate it ref angle. That word reference is kind of long. Do you know what degree measure that reference angle has? Well, I know that from the positive x-axis to the negative x-axis, that's 180 degrees. It's just a straight line. But we had to get all the way to 210. So 180 plus what got us to 210? That's 30 degrees. So in this case, our reference angle is 30 degrees. Note that your reference angle will always be between 0 and 90. We're looking for kind of the smallest angle we can see, as long as it's between the terminal ray and the x-axis. I can't stress that enough. I'm not really caring about the angle between the terminal ray and the y-axis at all. Let's do another couple of examples. How about 135 degrees? Let's sketch that in standard position. If I think about how far I'm going to get to 135 degrees, I know that I would land in quadrant 2. Our reference angle is formed by the terminal ray and the x-axis, and it's the angle between 0 and 90. So 135 is not going to be the reference angle because that's not between 0 and 90. This is our reference angle right there. So let's think, what is the measure of our reference angle? Well, I know all the way down would be 180. We only were at 135. If you do some subtraction, our reference angle here is 45 degrees. Notice it's between 0 and 90. What about negative 60 degrees? Let's find the reference angle for negative 60 degrees. Initial ray. It's negative, so I'm measuring clockwise, 60 degrees. So there's our sketch of our angle. And then our reference angle is the angle between the terminal ray and the x-axis. So this is our reference angle. And you might say to yourself, wait a second, isn't that just 60 degrees? And you're absolutely right. So notice the reference angle for negative 60 degrees is 60 degrees. Our reference angle, though, will always be positive, and it will always be between 0 and 90. So even though we sketched a negative 60, our reference angle was still 60. Let's try this example. Draw an angle whose terminal ray lies in quadrant 4 and whose reference angle is 30 degrees. Let's try to sketch that. All right, there's my XY plane. Terminal ray lands in quadrant 4. Don't forget how your quadrants are numbered. Quadrant 1, 2, 3, and 4. So it has to land here. And our reference angle, which I can see is this one, has to be 30 degrees. So let's say I wanted the measure of this angle in standard position. Let's say I wanted a positive angle. How far is this? Well, all the way around is 360, but we had to stop 30 degrees short. So I could say that this angle has measure 330 degrees. That angle measure satisfies the criteria of the question. Or what if I wanted a negative angle and I wanted to just measure it down like that, measuring clockwise, just going 30 degrees would be an angle measure of negative 30 degrees. Or I could go around more than once and land there, going 360 degrees plus another 330 degrees, and go 690 degrees. Or I could go in the other direction, more than once and go negative 390 degrees. You can see that there's infinitely many angles that will be coterminal with each other. So if I was interested in just one of them, I don't know, maybe I just picked that first one. It's nice, it's positive, and I've gone around less than once. But note that there's infinitely many angles that are coterminal with each other that match the criteria. So the goal is to be able to sketch it and then be able to give some numerical value for it. You'll see that this angle stuff is all really about definitions and how we sketch them. And if you can really remember, what are some important numbers? 90, 180, 270, 360, those are some important angle measures that you'll need to sketch other angles, then you'll probably be okay. Good luck.